Hello.
Hello, Professor.
Hello, Professor.
Yeah, how are you guys doing? Okay. So let's wait a couple more minutes. I think students are still joining. Let's see. Okay, let's start. So I'm going to share my screen. I'm assuming you see my screen now.
Yes, Professor.
Okay. So yeah, hello everyone again. So yesterday we covered data visualization, especially with Tableau, right? And I hope like you had some time like playing with Tableau. And so did you guys get my Tableau workbook that I sent yesterday? Right. So like actually that's the workbook that I created during the class yesterday. So like if you couldn't follow me or if you missed something, you can just open it and then you can like play with that and then just practice. Okay, so today we are going to cover like text analysis, and especially I would like to focus on like getting text data from Twitter and then like how to analyze that. Like of course, again, like as Tableau, this is a very broad topic, but I'll just like mention some basics, and then if that, let's say, yeah, attracts like if that get your attention, I'll be happy to provide more resources after the class. So like before actually doing that, so let's make sure is everybody have like does everybody have our studio right now? Is there anyone who's having difficulty installing? Any issues? No. Okay. So yeah, like today's class will also be like hands-on. So like most of the class will be on our studio. So I'll be the like doing the coding, and then like if possible, please follow me along. Okay. And again, like yesterday, we mentioned the issue of like having one screen, but I think if you just the screen for today's class, it should be fine. Okay, so let's start then. Okay, so let's talk about like generally what can we do with the social media data. Okay, and these days it's very popular, right? Because social media, like people spend a lot of time, and we will see some statistics which are very shocking. Like people spend a lot of time on social media, and that's also a good thing for like for businesses who wants to like use that data. So here's an information that's the like 2020 information, by the way. So this is what happens in an internet minute. Okay, in 1 minute, let's look at some of them. Like people like type 4.1 million search queries on Google search engine. Okay, and in 1 minute, people watch like 764,000 hours of Netflix videos. Okay, and you can see that like these numbers are huge. Like for example, in just 1 minute, around 200,000 people are tweeting. And probably these numbers are way higher right now if you just look at the 2021 data. And here, this is telling us about the invasion of the internet. And again, this is a 2019, like pre-pandemic data. Probably these numbers are huge right now. So this is the total population in the world, and then this is the total number of like unique mobile users, like almost like two-third of the world uses mobile devices, and then this is the number of internet users, and then you can see this is the active social media users. So almost like half of the world uses social media. Oops. And here, does this sound familiar? This left one. So have a read. Yeah, again, like these are by the way, like somehow like old cartoons. Like you see, this is 2013, I believe. The things are getting way crazier these days, right? And again, this is the time spent on social media. So average daily time spent on social media, like people spend like 40 minutes on YouTube, 35 minutes on Facebook, 25 minutes in Snap, and 15 minutes. And again, these are these are a couple of years data set. Probably these are right now way more higher than that. And this is very shocking. Like this is the average time spent on social media in a lifetime. So an average person in the world like spend 5 years, 4 months on social media. And this is what it looks like when you compare that to common daily activities. So a person on average watches TV like 7 years and 8 months of like watching TV in their day lifetime, and probably huge amount of this time is now switched to this social media, right? And here it is like comparing to eating and drinking, right? Like people spend time on social media more than they spend time on eating and drinking and socializing and doing laundry and so on. Right, so again, like many other examples, right? This is it's very funny. So have a read. Right, this looks very familiar, at least to me, and probably like some of you as well. But let's see, what's the definition of social media? Okay, so social media, a group of internet-based applications that build on the ideological and technological foundations of Web 2.0, and that allow the creation and exchange of user-generated content. Okay, here, the key word is the user-generated content, okay? And you know the story of like Web 2.0, right? Right now we are using Web 2.0 and the difference between that and Web 1.0. So here, like anybody can generate something. some kind of content. Okay, and because of that, like there are many platforms in many different categories that you can think of. Let's say, like if you are interested in, let's say, like music, like Pandora, and then like pictures, Flickr, right? Like social bookmarks, like comment, reputation. These are platforms, all like in all of them, like users generate something, okay? Not the platform itself, the user generates something, right? And most obvious ones are like Facebook, Instagram, Twitter, right? All these are some kind of blogging sites for people, right? And right now, this is huge, right? Like there are many different type of platforms. So what can we do with all these social media? So let's say, so can you, does anyone have any idea like what you can do with this social media data? How you can use it? Let's say you're a business person. Okay, it can be any type of business. Can you give me an example where you can work with social media, just improve your business model? Any idea? Like someone,
Professor,
yeah.
I will say my experience when I use WeChat to talk with my friends about a word like iPhone, this word. So the Chinese app to sell some goods will advertise me to the iPhone.
Yeah, right. That's pretty common, right? Like even there are some like scary versions of that. Let's say even like you're not using any kind of app, you're just talking to your friend, let's say about something, and then that suddenly appears in your like a web browser, right? So that's pretty common, right? So let's say like even like let's say you want to buy something, a car, let's say, and then you're just searching for that, like just to get some information about the car, and suddenly those cars appear everywhere on the internet for you. Yeah, that's one thing. And like the other one is probably these days pretty popular, like probably you heard of like influencer marketing, right? So one day, let's say, is there any influencer among us right now? No. Yeah. So for example, let's say you're let's say you create a new product, and then you wanna make sure everybody heard of that product. And these days, one of the most popular ways of doing that, you just like, let's say, make a deal with an influencer. But when I say influencer, I mean like, let's say, Twitter influencers, Instagram. We can think of any platform, and then like they somehow advertise your product, right? And then based on that, like majority of people like hear about your product, right? That's the influencer marketing. So for example, what we can do is, like, there are a ton of influencers, right? How you're going to select that, right? Let's say you're going to deal with like 10 influencers, because there's a cost, right? You cannot just deal with every single influencer in the world, right? So you're going to select, let's say, n amount of influencers, but there are a ton of them. Which ones to go with, right? That's a pretty popular topic, and actually that's one of the like research that I'm working on right now, like finding those influencers. We call them usually in network analysis, we usually call them as seeds. Okay, so how do you find those seeds so that your information, product, anything spreads to the network as fast as possible? Okay, so there are many things that we can do with social media. Okay, those are just some information, like examples. And here's a very nice way of explaining different types of social media platforms. Okay, and I think this is pretty correct, right? Yeah, like why this is important? Any idea? Why it's important to know these differences? Like just think about it from a business perspective. Why this matter? Why does this matter? Any thoughts? So it's all about your problem, right? The problem that you're solving. Let's say if your audience is like teenagers, you should probably go with Instagram, right? You should probably collect data from Instagram. Like if your audience is teenagers and if you try to collect data from LinkedIn, then you might be solving your problem in a very difficult way. But at some point, maybe it's impossible, right? So it's good. Like each platform has its own characteristics. Okay, so it's important to know that. And here's another example, right, of people in different types of platforms. Okay, so now we know that it's important to, like, especially like if you are working in this area, it's important to be able to collect data from social media, right? So there are different ways of collecting data from people. Like earlier, like I want to say earlier, like people still use surveys, right? They just conduct surveys and then that way they collect the data. This is still a valid way of collecting data, okay, because you cannot get everything from social media. But now majority of people, especially researchers, are doing, like, they're just collecting the data from the web itself, okay? And so yeah, I'm just going to talk about like how we can collect the data from the web, especially like mass amount of data. So the basic way, the most naive way, is web crawling, okay? And that means you just write a program that visits the website that you're interested in. Okay, it can be, again, Twitter, let's say Amazon, or whatever that you're interested in, that goes to the website and then collect the information for you. And obviously, this requires programming proficiency, right? And the other option is these APIs, okay? That's when we say API, it means a software system designed to support interoperable machine-to-machine interaction over the network. So the provider, for example, Twitter, provides an API, which is application programming interface for the database. So technically, API is going to be a tool that will help you to connect to the database of the provider so that you can get the data from there rather than like crawling that data. And the third option is there are some third-party applications like paid or freemium programs, okay? And in this case, you don't need any kind of programming. You just use their tools, like for example, Tableau, right? Let's say if you use R or Python to create your visuals, you have to write some amount of codes, right? Some amount of code is required to create a nice plot. But in Tableau, it's a paid program, and it's a lot easier. You just drag and drop the variables, and then you create pretty nice plots. Like similarly, like there are some third-party programs like Hootsuite. You just by just clicking, you collect data from different platforms. But obviously, at some point, they might be pretty expensive. Okay, so And here today, as an example, I'm going to use the API, and as an application, I'm going to show the Twitter API. And I know that like probably many of you don't have the Twitter API access, which is totally fine. What I'm going to do is getting the data part. I'm going to use my own API, and at that point you will not be able to follow me along. You can just like watch me, okay, if you don't have any API access. Then once we have the data, I'm going to share the data with you, okay, because it's not going to be a huge data set, because it's just going to be for illustration purposes. Then everybody will have the data set, and we can continue working on it to do the text analysis. All right, any questions so far before we start? Okay, so let's see. So let me show the Twitter API, what it means. So let me see how many of you have API access right now. Can you just like raise your hand in the Zoom? Okay, so I have 2. If you don't have that's fine, okay, because it usually takes time to get access. So yeah, like as I expected, like majority of you don't have it. That's fine. So because like getting the like using R, there's a package we are going to use. Using R, it's very easy to get the tweets, and we're gonna get them like with a couple of lines of code, and then I'm going to share the data with you all so that we can work on that same data set. So yeah, if you have the access, you're going to have access to this developer portal. So let's go there. Why it's very slow. Okay, so once you have the access, you're going to have like here API. So I have 2 types of API access. Like one of them is academic, where I use it for my research, and the other one is, which is the most common one, is the standard API. Okay, and once you have an API, you just create a project, okay, and then you create an app. So technically, this app will have your like tokens. By tokens, I mean your some kind of passwords, okay? And then using those passwords in R, we're going to communicate with this API so that we will be able to get the data. So let's close this. Okay, let's open our studio. So things. Okay, once you open the R Studio, you will see this window, right? And like R Studio is built on like base R. Okay, you can also use base R if you want, but I think R Studio makes some things a lot easier. Okay, and also like user interface is I think way better than the base R. That's why people use R Studio commonly. So once you open R Studio, you will have these 3 windows, or you might also have another one, which is the editor I'm going to talk about. So this window is the console. Okay, this is the part where we put our code, let's say 2 plus 2, and then we see the result. Okay, so this arrowhead, that means R is ready for you to enter your code. Okay, and once you see that, you can add things. Let's say A is equal to, let's say 5. Okay, we just created a variable which is named as A, and then that holds the value 5. If I call A, hit enter, it's gonna give me the value of that variable. Okay, so this part is the console, and here this one will keep all of ours, like data sets, the variables. Okay, all of them will be here in this environment tab, and this part will help us like navigate the files which mirror your computer, and then the plots. If you want to install some packages, you have all of these, and then this help. This help one is pretty useful. Like, let's say if there's a function that you are using for the first time and you don't know what it does, you can just type the function name here, and then it's going to give you the documentation for that function so that it explains what that specific function does. Okay, so for example, there is a commonly used function in R, which is C. Okay, that stands for concatenation. That it technically take list of values and create a list. Okay, so let's say my list. Okay, that's how am I going to name it? Let's say equal. And to create a list of values, we usually use that C function C, and then put all the values by separating them with comma. Let's say 2, 5, 7. Okay, run, and if I call that list, it's going to give me like a list of 3 numbers. So for example, if you don't know what this function does, just put it here in this help window and then search for it. It's going to give you the function, and it's going to explain what that function does. Okay, like combine values into a vector list. Okay, all the things like what that function requires, like what kind of arguments you need to pass. Okay, everything. All right, so yeah, let's actually start. So what I'm going to do is, like, although all the code, all the result will appear in this window, we're not gonna usually, like, we won't usually write our code here. Okay, we usually write it in a document called R script, so that we can save it, and then later, if you want, we can keep working on it. Okay, so here you see this on the like top left, you see this blank document with a plus sign. So click that and then select the first one, R script. Okay, and then it's going to open a new window here. All right, this is called R script. So all the code that we are going to type will go here. All right. So let me show like some common things. And again, like some of you might be already familiar with this. So if you are that person, please bear with me. Okay, I'm just covering this for students who might not know these. So the good thing about like using R script rather than just putting the code into console is, like, one is we can save it. The other one is we can also incorporate commands. Okay, commands are really useful when it comes to programming, because later when you read your code, and if there is no command, then it might be very difficult to understand what that code is doing, even if you are the person like wrote that code. Okay, so for example, the first thing that we are going to put is, let's start with a pound key. Okay, so a pound key means everything that follows the pound key is a command. Okay, it's not something that is executable. Okay, R will not execute this. It's not going to give you any result. Okay, it's just there to explain what our code is doing. Okay, so we will start with setting the options. Okay, so here we're gonna start with this options saipan equals 999. Okay, options parentheses saipan 999. The reason behind this, okay, to avoid scientific notation in the results. Okay, that's the goal. Now, by scientific notation, what I mean is, like, sometimes you see the results as with that term E, right? You know this one, this term, like E. That's the like Euler's number, and we don't want that. Okay, that's sometimes like hard to read. So we just want to see the results as regular, like traditional numbers. That's why we need to run this. Now, once you put it here, that doesn't mean you're actually running that code. Okay, you're just putting it in R script. So to be able to run that, you need to highlight the part that you want to run, and then you either click this run, or you can just, as a shortcut, like Control Enter, or if you're using Mac, Command Enter. Once you do that, it's going to run the part that you highlighted and then put it in the console. Okay, once you see it in the console, then that means you ran that code. It's executed. Okay, putting it here does not mean you ran it. Okay, and here, like, once we create this new R script, it was named as untitled one, and as you can see, it is red and then has an asterisk. That means we didn't save it, and then this asterisk mean there is something that is not saved. Okay, so let's save this file. So I just put like Control S, and let's save it. I'm gonna save it to desktop, but you can save it anywhere you want. Okay, I'm gonna say lecture 1. So in Korea, it's right now 21st, right? Lecture 1, 21st, so January 21st. And if you save it, there you go. That now it becomes black, and then it just takes the name that we gave. Now, as soon as you keep typing, let's say, let's make a title. So as soon as you keep typing, that asterisk will appear again. That means now you have something that you added and you didn't save. So it's good practice to frequently saving your document. Okay, so I'm just going to make a nice header so that it's distinguishable. The first thing that we're going to learn is scraping the Twitter. Okay, again, this is just comment. I'm just making it just so that we can distinguish this part easily. Okay, now let me take my. So to be able to like scrape the Twitter and connect with the Twitter API, we are going to use a package that's called Twitter with capital R at the end. And when I say package in R, is like, what I mean is, like here, for example, we use a function, right, to create a list. To create this list, we use a function. Now, this function is, when I say function, you need to understand a function in let's say, basic math. Okay, so this function has a name, which is seed in this case, and then takes some input. Takes some input and then gives you an output, and the output is a list. Okay, like this. But this one, to be able to use this function, see, we didn't do anything. It's already built in R. But there are some functions that we are going to need. Like, some people already prepared them, defined them, and then put them in a package, and then put them online. So we need to take them, like, we need to take it from their website, put it in our computer, and then import it to our environment that we are working right now. Okay, so and Twitter the package that we are going to use for Twitter API is something like that. Like someone defined those functions that will help us to communicate with Twitter API and then put them in a package called Twitter, right? So to be able to install a package for the first time, we run something like this. So install dot packages. So just be careful. There are two options. One of them is install, the other one installed. We are using the install one, okay? Install packages and parentheses. Now within quotation marks, double or single quote doesn't matter. Within quotation marks, we're gonna give the name of the package, which is Twitter with capital R at the end. Okay, this is the main package that we're going to use to actually communicate with the Twitter API. And the other package that we are going to use is, so go to next line, install.packages, parentheses, within quotation marks, it is write XL. Okay, these are the two packages that we will use. Now, the good thing is, if you are running these for the first time, like we just need to run these 2 lines of code once in our computer. Okay, let's put a comment there. So run the below 2 lines just once on your own computer. Okay, so these 2 lines will take those packages from the internet and then put it somewhere in our computer. Okay, let's run them. Oops, Control Z. Let's highlight those 2 and then run. So I already have them, so it might be a little faster in my case. Yeah, just wait. Okay, mine is done. So again, in order to avoid running these codes like by mistake again, I'm gonna put a pound key before them. Okay, so that I don't run them by mistake again, because again, we just need to run these once. Now, after we install those packages, we will actually import them now from our computer to our environment. Okay, so I'm going to say library Twitter, that's the first one, library write Excel, that's the second one. Okay, let's run these 2. Yeah, once you run them, you shouldn't have any error here. If you see it like this way, that means everything is fine. So if you are following me along, and then if you fall behind, please let me know, okay? And if I'm going too fast or too slow, just let me know. Okay, now we have the packages. So let's actually communicate, like set up authentication with the Twitter API, and then after that we will be able to actually like search the Twitter using Twitter API. Now for this one, we need 4 things. The first one is consumer key. And then I'm gonna go to the next line. The second one is consumer secret. The third one is access token. And again, if you don't have Twitter API access, you don't have to follow me along at this point, okay? Because these will not work for you. Just try to understand what I'm doing. All right. Once we have the data, again, I'm going to share the data with you. And the last one is access token secret. Okay. So I need these 4 values from my API. Okay, so what I'm going to do is I will go to my API. So let's go back to API. It's actually just developer portal. Well, it's very slow. Let's see. I might have my API tokens somewhere in my computer. So I'm just going to open that file. I think it's here. Yeah, there you go. So I'm just going to copy them here. So again, this, for example, this is my consumer key. This is my consumer secret. And usually, okay, you should not share this with anyone. Okay, these are like passwords. But again, at any time you can just regenerate them. Okay, like after the crossflow example, I'm gonna regenerate them. That's why I'm putting that here. But like once you have API access, you need to change these parts, like within the quotation marks, you need to put your own information, as I mentioned here, as a note. Okay, and again, at the end of the class, I'm gonna share this R script with you so that you can play with that later if you want. Okay, those are the information that we need from the API. Now, using that information, we're going to set up the authentication. Okay, so set up Twitter auth. Okay, that's the function that we're going to use. Now, the good thing with RStudio and Base R, I think, does this as well. Once you keep typing, if that function is available already, it's just going to, like as it just did, it's going to recommend a function to you. Okay, so rather than typing it by yourself, you can just select and then have the function ready. Now, this function requires 4 things, these 4 things. So consumer key, consumer secret, access token, and access token secret. Okay, all these 4 values are coming from here. Okay, so what I need to do, but I already put these 4 values here, but I didn't run them. So it's not in the memory right now. So it's not, I didn't execute them. What I'm going to do is I'm going to highlight these 5 lines and then run them. So now, if this is the first time that you're using Twitter API, it's gonna ask you a question where you need to enter 1 and then hit enter. But because this is not my first time using the Twitter authentication, it's just going to use my previous authentication. Okay, now we have authentication for the Twitter API. Let's actually get some tweets. Okay, is there any topic that you're interested in? So let's see, let's search for a keyword. Okay, the first way of getting tweets is based on a keyword. Okay, let's say it might be a hashtag, it might be just any topic. Okay, so let's say, let's get tweets about, any idea? Maybe 5G, or if you have any recommendation? Is there any trending topic right now?
Bitcoin.
Bitcoin, yeah, let's go with that. That's a good idea. So yeah, the function that we're going to use is search Twitter. Okay, that's the function. And then this function, now here, obviously you might not know what this function does, right? But always just go to this help window and then just search for the function. So search Twitter, for example. And then it's going to explain what that function does. Okay, all the arguments that function takes. For example, search string. That means here, the search query to issue to Twitter. If you have more than one topics, let's say Bitcoin, let's say crypto, let's say you have like a couple of words that you want to check, you just use like plus sign to separate them. Okay, and then the next argument you use is how many tweets you want. Okay, by default is 25. And then the language, let's say you can specify to, let's say Korean, or you can specify to English or any language. You can specify the from when, okay, the since and until. Okay, there are many things that you can specify. So let's go easy at this point. So let's say we're interested in Bitcoin, right? So Bitcoin. So because Bitcoin probably is going to be like let's say discussed all over the world, let's just focus to English tweets. Okay, so I'm gonna say lang en for English. Okay, and then let's say n is say 1000. And here, like one thing that you need to be careful here is, so I show two types of API, right, at the beginning. For example, in my account, I have academic research one, and I have the standard one. So if you go with the standard one, you can only get tweets for the last week. Okay, so if you want to collect tweets, let's say about Bitcoin in 2019, you need to have academic research account. All right, but for the purpose of like illustration, this like standard one will work for us. So let's say let's get like 1000 tweets and then like English tweets. Is there anything that we want to? Yeah, I think that's fine. Now this function, when we run that, it's going to give us all the tweets. Now we need to give a name to that result. Okay, so we're gonna give them, we're gonna say tweets. That's the name that I'm going to give. Okay, so this function will give us 1000 tweets, and then it's going to put them in this tweets, in this object named tweets. So let's see. Then to make like by default, these tweets will be list of tweets, okay, which is hard to work with. What we want to do is we want to put them in a table, okay, where each row is a tweet, and then for each tweet we will have number of likes, number of retweets, the text itself, okay, the username, okay, who tweeted, right, that kind of information. So we will use another function, which is, so I'm gonna call it tweets df, that stands for tweets data frame. And we will use a function called tw list to df. It's gonna recommend you the function. Okay, what this function will do is it's gonna take the tweets as list and then convert them to a data frame, like row column format. Okay, just take the tweets which are coming from previous line. Okay, and here's a, yeah, I think that should be fine. So let's run these two. And again, if you don't have Twitter API access, obviously you're not going to be able to run this, but just wait. Let's see, it's getting tweets. So it's still running. For some reason, everything is very slow. There you go. I think I have it. Yeah, so I have 1,000 tweets. They appeared in my environment, and I can see that now console is ready for my next code. So here we have this tweets df. Now, if at the end you see this like table icon, let's click that, and then we can visualize it as a table. Okay. So here, now each row is a tweet. Okay, and then for each tweet we have the text, like tweet body, like favorite count, like number of likes. Is this tweet a reply? Okay, if so, like who is it replying to? And then when this tweet created. So this, for example, the first one is created. It says what? 0149. Yeah, probably this is a different time zone. And like truncated, let's say we have that reply to, and then these IDs, the source, okay, this one will tell us like what is the device they used to make the tweet. So the first tweet is coming from Twitter web app. The second one is coming from, for example, iPhone. This one is coming from Android, okay? And then the screen name. Screen name is the username, who tweeted. Okay, that's the screen name. So this is the retweet count, like how many times it's retweeted, and so on, okay? So this way we have 1,000 tweets. All right, now let's do this. So that's how you like search for a specific keyword, okay, using the search Twitter function. Now I'm going to show the second way of getting the tweets. In some cases, you might want to be interested in, let's say, getting tweets from timeline of a user, okay, of a specific user. By the way, I'm going to save this so that we don't lose it. So let's go there. So here, what I'm going to do is we can also get tweets from a user's timeline. Okay, so to be able to do that, we are going to use another function that is available in this Twitter package, okay, which is the timeline, sorry, user timeline function. So what I'm going to do is, let's see, so timeline, okay, that's how am I going to name it. So user timeline, that's the function that we use. Okay, user timeline with capital T. And this function, again, if you don't know, just search here, like user timeline. Let's see what this function does. So it says, these functions will allow you to retrieve various timelines within the Twitter universe. So user timeline, what it takes, it says the user, the screen name, okay, the number of tweets that you want, and so on, okay, like similar scenes that include retweets and so on, okay? So you might just, let's say, you might just want to focus on the tweets rather than retweets, okay? There are many options that you can like adjust, okay, in this user timeline. But let's see, is there any user that you wanna get the timeline? Maybe since we went with Bitcoin, let's go with Elon Musk. So let's get the, and again, if like, because right now we are using the standard API, we can only get the like tweets from last week, okay, last 7 days. So let me put that as a note. So Twitter restricts this to be to last 7 days. Okay, so the user is going to be, let's say, Elon Musk. I think that's the screen name, not Musk, right, for Elon Musk. And here, let's say n is 1000. Again, because Twitter restricts this to the last 7 days, we might not get 1000 tweets, okay? And I know that like Elon Musk tweets a lot, so we might actually get 1000 tweets. But let's see how many we will get. And again, as I did here, I'm going to convert the result of this to a data frame. Okay, so let's say timeline df. I'm going to use this same function twlist to df, and then take the timeline object and then convert it to a table, row column format. Let's run these 2 lines. There you go. Let's see how many tweets we will get from Elon Musk. Wow, 343 tweets in 1 week. That's a lot. Okay, so let's see them. So I'm gonna go to this timeline df, which has a table at the end. Click that table icon. And here, so as you can see, this tweet, like Elon Musk is replying to this user. And this is the number of likes. Let's see, right? And he's using his iPhone, obviously, for all his tweets. We can see that. He's tweeting all of them using his iPhone. And the screen name is will naturally be Elon Musk itself. Right? So we have like tweets from Elon Musk and then tweets about the Bitcoin. So here's what I'm going to do is, again, because like many of you didn't get these tables, what I'm going to do, I'm going to create a table which includes, like, combines these 2 tables. And then Mr. Kwon, if I send this table to you right now, are you able to share them with the students?
Yes.
Yeah, right, okay. So let's do that. So what I'm going to do is, first, I have 2 tables, right? Tweets and timeline. What I'm going to do, I'm just going to, let's see. Yeah, I'm just going to combine them in 1 table and then write it to an Excel file. And I'm going to share that Excel file to you, with you, like probably using Kakao. And then you can share it with the students, so that from now on, everybody can follow me along. Okay, so let's first, I'm going to say all tweets. So we have tweets for Bitcoin and tweets from Elon Musk. So all tweets. I'm going to use a function called rbind. So that just combines 2 tables. Okay, rbind. The tables will be the tweets df table and timeline df table. Okay, we'll just combine those 2. Let's run this. There you go. And now I'm going to write that table to an Excel file. So for that, I'm going to use a function called write xlsx. Okay, and this just requires the table that you're writing and the path, like where are you putting it. So what I'm going to do is, let's just name it as all tweets dot xlsx. So let me run this as well. There you go. Now, if I go to my desktop, where is it? Oh, did I change my working directory? No. Okay, right now, like I thought my working directory is desktop, but obviously not. So this went to somewhere that I don't know. So I'm gonna make sure I will just click the files and then go click this triple dot and then go to desktop, open, and then make sure desktop is my working directory. Okay, now if I run this code again, it's going to put that on my desktop, which is here. So if I go back to my desktop, here, all tweets. Oh, yeah, I need to put this in my Google Drive so that I can send with my others. Why not? Oh, let's see. Let's put it here. Okay, now I'm gonna send it to you via Kako. Okay, let me see. It came. There you go. So it's not a large file. I'm assuming it's going to be very fast. Yeah, I just wanted. Yeah, you should have it.
I just uploaded on Prato and our student can see Excel file.
Okay, so let's do this. So please, like everyone, just download that file to your computer. Okay, from probably the learning management system. So just download the file, probably to your desktop or wherever you want. So I'm gonna wait 1 or 2 minutes for people to do that. Again, just you don't have to open it. Okay, do not open the file. Just download it to your computer. Okay, is there anyone who is still downloading? I guess everybody's done. Yeah. So assuming that you downloaded to your computer, like somewhere on your computer, desktop or whatever, now I'm gonna show you how to read that file. Okay. So let's see. I'm gonna make here on our studio. I'm gonna make a new. Oops. Oh, the language changed. Okay, the next step is text analysis. Okay, text analysis of tweets. Now here, I already have the data file like tweets, but just to show you how to do that, I'm gonna do it again. So now I'm gonna show how to read that Excel file into RStudio. Okay, so do you see this file at the top left? Click the file, and then you will see this import data set. Okay, from this import data set, select from Excel. And then it's going to open this import Excel data window. So here, what you need to do is click the browse. Now, in my case, the data, the data is, in my case, the data is in my this MGIS 650 folder, but wherever you put your data, just go to that folder and then find the data here, all tweets, and then click open. Okay, find the data wherever you downloaded it, click open. And once you have the data, still we are in the same window, import Excel data window. Make sure the name of the data set is all tweets. Okay. And then uncheck this open data viewer. Okay, we don't want that. Just uncheck open data viewer. All right, the rest is fine. Okay, just click import. And then you should have all tweets data frame appearing in your environment here. And then it should have 1,343 observations. So let's click that table icon at the end here. And then you can actually see all the tweets in one table. Okay, these are tweets from Elon Musk and then tweets about Bitcoin, or tweets that contains the word Bitcoin. All right. Any issues? So does everybody have the tweets now? Is there any part that you want me to do that again? I'm assuming everybody's fine. Okay. Now, so let's see. The first thing that we are going to do is, like, first of all, to do the text analysis, we are going to use a package named quant-EDA that stands for Quantitative Exploratory Data Analysis. So we need that. So install .packages quant-EDA. Okay, that's the name of the package that we will use for the analysis. Let's run this. And again, I already have this package, so it might be way faster in my case. Okay, mine is done. Let's wait. So once you have this, just put a pound key at the beginning so that you don't run it by mistake later again, because again, everything that follows, like starts with install packages, you just need to run it once on your computer. Then once we have that, now we actually need to import that package to our environment using this library function. So quant-EDA, and run that. Okay, you might have some like warnings like this. Those are totally fine. Okay, now for the text analysis, we first need to create a corpus. Okay, and the corpus, but when I say corpus, I mean the body of text that we're going to analyze. And in this case, the body of text will be the tweets, right? So let's see, I'm going to name it as R corpus. Okay, that's how am I going to name it? Like, these are all names. You can name them however you want, but that's how I name, how am I going to name them? So our corpus is equal to, the function is called corpus. Okay, that comes from this quant EDA package. And we're going to use all tweets. Okay, all tweets data will be our corpus, but here we need to make sure we are just getting the text part of those tweets. We don't want the number of likes, number of, let's say, retweets. Okay, so I'm going to say text field within quotation marks, text. And this text is referring to the text column. If you go back to the all tweets data frame, click that table icon. You see this when I say that text in the code, I mean this text column. Okay. So we're just going to use that text column as the body of text. Okay. So corpus is the body of text that we will analyze. So let's see how many documents we have in the body of text. So NDOC, that stands for number of documents in our corpus. So let's run these two because so far we didn't run them, right? Let's run these two. There you go. We have 1,343 tweets in our data, in our corpus. Okay. Now, so first thing that we will do. So actually, let's see our corpus first. So I'm gonna say head. I'm gonna run it here actually. So let's see the head of the corpus. By head, I mean the first couple of documents. So head, parentheses, our corpus, and then run it. There you go. So let me put that there. Here, so it's just going to show the first 6 tweets, okay? That's why we said head. So here, this is the first tweet. That's the second one. That's the third one. Okay, that's the fourth one. Okay, these are all about like Bitcoins. Now, what we are going to do is in the text analysis, the first step is we need to represent these tweets, these texts, as tokens. Okay, when I say token, I mean this. Let's say if I have a sentence like this, let's say I love, let's say Samsung. Okay, let's say that's the sentence. When I convert this sentence to tokens, it's going to be like this. It's going to be a list of words. Okay, I love Samsung, and then the dot. All right, it's just going to take the punctuations and then the words as tokens. All right, so what we are going to do is we are going to convert every single tweet to tokens like this. So let's do that. So to be able to like convert them, we're going to use a function called tokens. So I'm going to say our tokens, that's how am I going to name it, is equal to tokens, take our corpus, and then convert the tweets, convert the documents in our corpus to tokens. And here, what we're going to do is, like here, if you do not specify, it's going to take the punctuations as tokens as well, which are not useful in most cases. So we can, there's an argument that we can use, which is called remove punct. And then you can just say true with capital letters. Okay. So now let's run this. Okay, now we have our tokens. Let's see this time, let's see the first couple of rows, okay? So I'm gonna say head, our tokens, and run that. There you go. Now here, actually, let's go with our corpus 1, like our corpus comma 1, and run that. That means it's just going to show the top, the first document. And then I'm going to say our tokens comma 1. Let's run this. Oops, let's run that as well here so that we can easily compare them. So, like as you can see, this was the original tweet, right? And this is the tokenized version of that. So as you can see, every single word becomes a token. Okay, like Coinbase. Every single word becomes a token. It's clear, right? Did you understand what's the meaning of tokenization? Okay, now every single document is tokenized. And obviously you can think that like every single document might have different tokens, right? Because they have different words. Okay, that's the idea actually. Now, what we don't want is like in these tokens, do you see these terms like the and, for example, for? So these are called stop words, right? So they're not needed actually. We don't need them in the analysis because they don't have specific meanings. I mean, in some analysis, you might need them, but in this case, they don't have any meaning, so we don't need them. What I'm going to do is, from all the documents, I'm going to remove these stop words. All right, so I'm gonna do that here. So what I'm gonna say is our tokens non-stop words. Okay, it's an ugly word, ugly name, but again, it's descriptive. Okay, when you name things, try to be as descriptive as possible so that when you read that code later, it's easy to understand. Okay, so our tokens non-stop words. So there's a function called token. Let's see. I think it's tokens. Yeah, tokens underscore select. Okay, that's the function. Again, I'm gonna keep repeating this. Like all these functions are new, right? To probably all of you. That's totally fine. Always, like if there's a function that you don't know, just go to this help bar, like help search. Okay, just go there and here click help and then search for it. And of course, you can also Google it rather than using this help window. It's going to explain what it does. Okay, this function select or discard tokens from a tokens object. Okay, and you can define many things. So for example, you can define a pattern. You can have like say specific words that you want to remove manually. Okay, it doesn't have to be just stop words. It can be anything. All right. So here, what I'm going to say is take our tokens, okay, as the input, okay, from our previous lines. Take our tokens, and then the pattern is here. That's the argument, right? The pattern is stop words in English. Okay. Now here, let's see. So let me run stop words here. So there's a function called stop words. Okay. And then by default, it's English. If you run that, that's gonna give you the list of stop words available in English. Okay. So here what we are saying is my pattern is stop words. So if any of the tokens in this our tokens object is in this list of stop words, remove it. Okay, that's what we are saying here. Okay, pattern is if any of these tokens is in this list of stop words, remove it. And how we are going to say selection is equal to remove it in quotation marks. So that way it's going to remove. You can also say keep. If you say rather than remove, if you say keep, that means it's going to keep the stop words only. Okay, keep. And let's add another argument, which is called min underscore char. Okay, or sorry, min and char, number of characters. Let's say 4. The reason that I add that, for example, what it's going to do is if a token has less than 4 characters, it's going to remove that as well, not just stop words. Stop words will be removed, but for example, buy, it's not a stop word, but because it has less than 4, it's going to be removed as well. All right, but it seems like we might lose some useful like tokens. So let's remove that actually. Let's keep it. So I'm not going to have any minimum number of characters argument. All right, let's run this. Okay. All right, it ran. Now let's see these our corpus, our tokens, and then our tokens non-stop words. Okay, I'm gonna say head our tokens non-stop words, comma 1. So just show me the first one. So let's run this first, line 43. I'm gonna highlight that, run it, and then see the tokenized version of that, and then see the tokenized version of that without the stop words. There you go. So let's go up a little. So here you see this was the original document, the tweet. This is the tokenized version of that. As you can see, every single word becomes a token. And then this is the version without the non-stop word. So for example, we see, like here, we see 4, right? After Peloton, it's gone. For example, and it's gone. The is gone. All right. If I had used that min number of character equals to 4, probably this use will be gone as well, or this by. But because I didn't use it, they're here. All right. Is this clear? Okay. Now, the next step is creating a document feature matrix, but that requires some kind of like a little explanation. So let's actually take a break at this point, and then we'll continue with wherever we left. All right, so how about this? So let's meet at, according to your time, 11, what's like 11:43? So let's take 20 minutes break. Okay, I'll see you at 11:43 then. Okay, let's continue. So yeah, the last part that we left was like getting our tokens without the non-stop words, right? And the idea was again just to remove these and the for these kind of stop words, okay? Because they might not, that they in this specific case they're not going to help with our analysis. Okay, now once we have the like the entire body of text, like this entire all the tweets like tokenized without by removing the non-stop words, we can actually create a matrix which is called document feature matrix. Okay, so now we will construct the document feature matrix. Okay, and this matrix will be like this. Okay, so let me open an Excel file just to show you how it works. Okay, so let's say we have 3 tweets. Okay, let's say 3 sentences. Let's say I love, I'm gonna put it here. I love, let's say Samsung. The second sentence is let's say walking my dog, and then let's see, so say this is cool product. Okay, let's say these are like very short sentences. So here, this sentence, the first one will be tokenized as like this. I, right? And then love Samsung, that's the first one. The second one will be I, let's say same love walking my dog. That's the second sentence, the tokenized version. And then the third one is this is, let's say we are also including the stop word. This is a cool product. Okay, these are the tokenized versions, including the stop words. Now, from these tokenized versions, we create the document feature matrix, and document feature matrix looks like this. So they say document number. Okay, let's say we have 3 documents, and let's increase the size. Yeah. And for each token, we will have a column. Okay, let's say the first one is I. The second one, what else you like this? Yeah. Yeah, the second one is, let's say, low. Third one is Samsung. The fourth one, again, we don't need to repeat the I and low because we already recorded them. It's going to be walking my dog. This, right, is, let's say, a cool product. So for every, again, for every single token, we will have a column. And then here, let's say it's going to check for the first document. Is I included in that document? Yes. So it's 1. Love included? Yes. Samsung? Yes. Walking, all these are 0. Okay, and this one, second one, I is included, love including, Samsung 0. So walking my dog 0, 0, 0, 0, 0. And for this one, these are 0, these are 1. Okay, so you got the idea, right? What a document feature matrix. So it just shows you like the documents in the rows and then tokens in the columns, and these numbers will be the number of times that token appears in that document. Okay, it doesn't have to be 1, 0. It can be, let's say, a word. Let's say if I say this, let's say the first one is like I love Samsung, then this will be 2. Okay, so this is the document feature matrix. Now we're going to create this one using our tokenized tweets. So let's go back to our studio. And for this one, this quant EDA, and again, let me mention that again, all the functions that we use here, tokens, token select, corpus, all these functions are coming from this quant EDA library, okay? So let's create our document matrix. I'm gonna say our matrix. And again, you can do a better job naming the things, but just be as descriptive as possible when you name things. So the function is DFM, okay, document feature matrix, and it just takes the tokenized words, like your corpus. You know, in this case, let's use the non-stop words version. Okay, we don't want to include this stop words. So in our version, we're not going to have, for example, these 2 columns because those are stop words. Okay, let's run this. I'm gonna highlight it. You don't have to highlight it. You can just like have your cursor on that line. That's gonna be enough. If you just click run, it's gonna run that entire line. Okay, and let's see. And here in a document feature matrix, each column is called a feature. Okay, so let's see how many features we have. So n feet, our matrix. Let's run this. So it says 4,314. So does anyone know what's the meaning of this number? What does this number tell?
Features, number of features.
Number of features, but in the context of tweets, can you say anything? So these are this tells us that how many tweets we had. We had 1,343, right? So in our data set, we have 1,343 tweets, and among those tweets, there are 4,313 non-unique, non-stop words. Okay, that's this number is telling us. Okay. Now, once we have this number, the first thing we can do is we can actually see what are the words, the tokens that appear the most frequently. Okay, so let's see the most frequently appearing words or tokens. Okay, and to find that, we can just say there's a function again in this quant EDA called top features, and then take our matrix as the input, that document feature matrix, and show us, let's say top 25. Okay, top 25 features. Let's run this. There you go. So let's see. So here, RT is the first word that appears the most. So this RT appears 581 times in those tweets. And obviously Bitcoin is the second one, right? Because this is the first tweets. We had like 1,000 tweets about Bitcoin, right? Which is obvious. And this dollar sign is the second one. Actually, what I want to do is and this one, probably if you're following like Bitcoin, you're familiar with this icon, right? This rocket icon. So they use a lot with the Bitcoin tweets. That's why we see it. Right, let's see, follow, good, best, Bitcoin, AMP, just, luck, right, crypto. So let's do this. Actually, we can remove these icons, okay? But let's leave them. So these are, yeah, this is the top 25 features that appear the most. And the first thing that we can do is another very nice thing that we can do. We can actually create a word cloud. Okay, and for that we need to import and install and import another package, which is called here. I'm going to do that here. Install.packages quanteda.textplots, right? That was the name. Yeah, textplots. Let's run that. So it's going to install it. And I'm just going to comment that out so that I don't run it again by mistake. Let's wait. There you go. Now I can actually import it. So library EDA textplots. Okay, now using the function, let's say, so let's create a word cloud. Okay, to visualize the tokens that appears the most. And the function for that is textplot word clouds. What happened? Something is wrong here. Let's see. It says corrupt. Why? One EDA textplots. Let me try running it this way. Quant EDA. There you go. Okay, it's giving me an error. So what I need to do is I need to uninstall this Quant EDA textplots and then reinstall it. So let's see, where was it? The C. I'm gonna go there. No, that. So I think it was in the C. Users. Documents. Or in library 4.1 and Quant EDA textplots. So these are all the packages. So I'm gonna remove this. What? Okay, let me close the RStudio completely. And now let's delete it. Yeah. I'm gonna close the. Okay, sorry about that. Let's see. Okay, now I need to run everything. So let's run this one. So I need to make sure quant 88 text plots are here. Yeah, should be fine. Run that, run this, oops. And then what else I need to run? I need to get the data again because they're all gone, all the environments. So file, import data. Okay. Now I need to run this one, this one, our matrix, top features, yeah. Yeah, now it works. So textplot word cloud, it takes the our matrix, and then let's say maximum number of words to include, let's say top 50 words. So for this one, the plot will appear here. So let's make some space for this plot to appear. And let's run this. There we go. So I think top 50 is small. Let's make it top 200. Yeah, these are, that's the word cloud, okay, of the top 200 tokens that appear. Right, and obviously you can see this, like Bitcoin is appearing a lot, but here what you can do is, like, because obviously you might expect like Bitcoin to appear a lot, we can actually remove it from the tokens. Okay, like here, when we create our tokens in this line, like we just removed the stop words, right? We could also do this. We could do this one. So let's say create a list of words that you don't want to see. Let's say unnecessary words, and it's going to be a list of words. For example, we don't want to see the Bitcoin, okay, and then Bitcoin as well, like without the hashtag. Then we can just use it here. So I'm gonna run that. So here, rather than just using stop words, we can say unnecessary words, comma, stop words, and put them in a list. So it's gonna take the stop words and these unnecessary words out. Let's run this. There we go. And if we go there, let's build our matrix again. Top features. You see Bitcoin is gone. And if you create the word cloud again, where is it? Like this. And now Bitcoins are gone. This way you can actually like remove some unnecessary words. Okay, for example, like RT is probably represented for retweet, so that might be also something unnecessary. So I'm gonna include RT as well. And then the $sign, maybe that's not necessary as well. So let's run these again, our matrix again, and then the word cloud. There you go. But you got the idea, right? So you just need to play with it, okay, to get a meaningful word cloud. And of course, this is like word clouds are like risky for a specific topic, because you're gonna have like, especially like tweets are very short, right? They're very short text. So word cloud might not be the best way of like visualizing it. But now what I'm going to show is, now at this point, we can stop working on tweets. We can actually work with some, let's say, longer texts, okay? But here, again, if you are interested in like working with tweets, I highly suggest going to the website of this Twitter package. Okay, that's the common, so that's the package that we use, Twitter package in R. Okay, it has its own web page where you can get like all the functions that we use. They are here, okay, with explanations like what you can do with those functions, what each function does, okay, like what are the arguments that you need. Everything is here. The other one is like, if you're interested in like doing more analysis, like text analysis, the other one is the quant EDA, okay, quant EDA, that's io.io. And this is the main package that we used for the quantitative exploratory data analysis. Okay, the textual data. This package is also pretty like powerful package. Okay, now let's leave the tweets there. Okay, and, one more thing. And obviously, like once you have the tweets here, like as a table, row column format, you know how to export them, right, to an Excel file. Then you can just read this file using Tableau and then do your analysis using Tableau. All right. Okay, so let's continue with, so I'm gonna save the progress. Let's see some like creating some like textual visuals, okay, textual visuals, so that we can create like, for example, like very nice like text plot, like word clouds. I'm gonna make a title again. Say textual data visualization. I'm recording this lecture, entire lecture, right? Yeah. So that's good. So you can watch it later if you want. Okay. So for this one, I'm not going to use the tweets, because tweets are very short texts. I'm going to use a corpus which is already built in the quant EDA package that we are using, which is called the data corpus inaugural. So those are the inaugural speeches of the United States presidents, okay, starting from the first president all the way up to this last one, like Biden, okay? So they are longer texts, so they might give us a better idea, and might create like, we might create like better word clouds. So again, we're going to use the same library, quant EDA, and there is a corpus named data corpus inaugural. Okay, here, this is the corpus that we will use. So let's see what we have in this corpus. So names, parentheses, and then the corpus. Let's run this. So here we have, like, starting with the Washington, okay, the first president of the United States, all the way up to Biden. So we have the inaugural speeches of United States presidents. Okay, so these documents, like each one is a document. We're going to use this as the corpus. So let's see how many documents we have. So ndoc, number of documents, data corpus inaugural. Let's run that. So we have 59 documents. And then let's see what we have at the beginning of each. Like head, just to see the head of the, let's see, top 3 only. Here it is. So for example, the Washington's speech starts with like fellow citizens of the Senate and of the House of Representatives. So Washington, again, it starts with fellow citizens. Adams starts with like when it was first perceived and so on. Okay, just shows us a couple of words for the first 3 speeches documents. And let's see for each document what kind of variables we have. Okay, so doc var, so that's called for like document variables in this corpus. Let's run that. So here it is. So for each document, we have the year, what year was the speech, and then the president, the last name, and then president first name, the party. Okay, which party was the president belong to? Okay, we have Democratic, Republican, Federalist, let's see, Whig, Democratic, Republican, and so on. Okay, the majority Democratic and Republican. Okay, so that's the data that I'm going to use now. So first, what we need to do is, as we did in the tweets, right? In this case, we have just 59 documents. As we did in the tweets, we need to convert every single document into tokenized version. So we have to tokenize the raw data. Okay, if you see this, like data, let's say corpus, oops, make larger. Yeah, data corpus, okay, head, and just the first one, if I run that, so that's just an original raw text. Okay, now we need to create a document feature matrix, and what I'm going to do is I'm going to create it. Let's see. Let's see this. Yeah, let's integrate all the code in one line, okay, rather than writing like one by one. So I'm gonna say DFM inaug, so that stands for DFM inaugural. That's how I'm going to name it. DFM inaugural. So there's a function called corpus select, or sorry, subset. So actually, let's use entire corpus. So data corpus inaugural. We don't need to select anything. And at the end of this line, we're gonna add something like this. This means everything that follows, all the lines follow this symbol will be applied for this object. Okay, so here, for example, use the DFM function, and here we're going to remove stop words. We don't want the stop words. Let's say English stop words. And also, we want to remove the punctuation. So we don't want to see the punctuations in as tokens. Okay, so it's going to be true as well. Oops. And again, percent, right arrow, percent. So we're continuing on working on this object. Now we're also going to, let's say, trim like some of the tokens. So here it will say minimum term frequency. So that means if a token appears, let's say, less than 10 times, we're not going to include it. Okay. And then verbose is false. So this means if there's any error, do not like print any kind of message. So let's run this. So I'm going to run this line. Okay, so we have some warning messages, but that's fine. It's not an error. So we have the document feature matrix. Okay. Now let's create a word cloud from this. And because this is somehow a random process, we might need to set the seed. Okay. So set seed is like if you have any kind of like random process, just to like for the sake of reproducibility of the results, we have to set the seed so that everybody gets the same result, even if the process is random. Okay, so if you set the seed but use a different number, different integer, you're gonna get a different result. Okay, to get the same results, you need to put the seed as 42. Does anyone know meaning of 42? Any idea? Like this in computer science, this number is used a lot. Anyone? Any idea? It's about like somehow like pop culture related to. So do you guys know this book? Was this the Hitchhiker's Guide to the Galaxy. Do you know? Have you heard of this book? Anyone? This one. This is maybe this might seems familiar. Yeah, this one. This is a pretty like popular text, not textbook. Is a novel. Okay, and 42 is according to this textbook is the meaning of life. Okay, and this is a great book, so you can definitely read it. And after that, like you see 42 as well here in the body. So in computer science, if there's any random process, they usually set the seed to 42. Okay, it's a pretty common number, but it's not important. So as long as you have, let's say, I can just put 5. As long as you put the 5, you will get the same results as I do. But I like to keep it 42. Okay, now let's create a text plot. So text plot word cloud. Here we will just use the DFM inaugural. Let's run that. Again, we're gonna run these two together and then run it. There we go. So let's make it a little larger. Oops. So I'm gonna run this again. Still running. Still running. Well, maybe we should put some kind of, yeah, now it's done. Now, like by looking at this word cloud, what can you say? What does this tell you? For the speeches of all the US presidents, what does that tell you? Right, by looking at this, we can say that all of their speeches goes around government, people, nation, like country, let's say world, peace, freedom, citizens, right? Their speeches are going around these words, like all United States president speeches, like Constitution, America, right? Okay, now this is the basic word cloud, and again, as you can see in longer text, this works way better than tweets. Okay, because you can have a like better picture. For example, you can put let's say like chapters or the entire book as the corpus, and then create a word cloud. It might give you an idea about the topic of that book by just looking at the words that appears frequently. Okay, and let's like another way of using a word cloud is we can actually compare different documents in one word cloud. Okay, let's do that. So here, let's say compare documents using word clouds. So here, let's see. So we are going to select a part of the documents. So we're going to use corpus select, sorry, subset, not select, subset, and take the data corpus inaugural, entire corpus, and here, comma, we can hit enter to go to the next line. Like if you remember, each document had 4 variables, right? We have the year, the president, first name and party. So by using president, we're going to, let's say, just take the Washington, Jefferson, and Madison. Okay, these 3 president's speeches, and then we're going to compare them using the word cloud. So what I'm going to do is this. So president, that's the name of the variable, and you have to write it as it appears in your corpus with the capital P in this case. So president %in. Now I'm going to create a list of presidents that I want to see. So C, that was the function that we used to create a list. So I want to see Washington, okay, and then Madison, and then Jefferson. Right? Actually, let's go more actual, like recent. Let's compare Biden and Trump. So let's go with, yeah, Biden, Trump. So I'm gonna say Biden and Trump. Okay. So we're just going to get the speeches of these 2 presidents. Then after we get them, like this %, right arrow %, let me make it some space so that we can see the code. Yeah. The next thing is we are going to like tokenize these speeches, so tokens, and then remove punctuations, true. So we don't want the punctuations as tokens. And we're continuing. So we're gonna remove the stop words. So tokens select, remove, oh, sorry, just, I'm gonna say tokens remove, not select. Stop words of English, and continue working on the same corpus. Create the document feature matrix and still continue working on it. And group the document feature matrix, so DFM group them by, sorry, groups by president variable. Okay, and oops, we'll continue on that. And we want to remove the terms like the tokens that appear, let's say, less than 5. So DFM trim, minimum term frequency 5, and we don't want to see any message on the process. Then the last one is actually creating the text plot. So text plot, oops, word cloud, and there's an argument called comparison. Okay, it's not showing here, but it's truncated. So there's an argument called comparison, which is true. So we want to compare. So let's make some space for the text plot and run this. There you go. So I think 5 is too much. Let's say 3, so that we have more words. There you go. Now, like here, technically, what we are seeing is we are seeing the, like in one text word cloud, we're seeing the speeches of 2 presidents. Okay, so that we can compare. For example, Biden uses us, can, democracy, story, right? These words appear a lot in Biden's speeches. In Trump's speech, America, country, dreams, people, like American, these terms appear the most. And by looking at these, you can see what kind of topics they are mentioning a lot in their speeches. Okay, now let's see, what if rather than comparing 2 presidents' speeches, what if I want to compare the speeches of different parties? How do I revise this code? Do you have an idea? I'm going to copy the same code here. Rather than presidents, I want to compare the parties, right? If you remember, for each document, we have the party, right? I just need to update this line and then this line, right? The rest is the same. So let's do that. So president becomes party because we are comparing parties. And let's see, I'm going to select Democratic Party, weak, and then Republican. Okay, so let's see, Democratic, and you need to be careful. It should, like, you should put the word as it appears in the corpus. Democratic, and this is Republican, then this is weak. So we are grouping them by not president, by party, and then the rest is the same. Let's run this. There you go. Still running, still adding some words. Still adding. Yeah. So here, let's see. If you look at the weak party, like constitution, government, power, states, union. So these are the words that appear a lot. So Democratic Party, again, same, US, nation, democracy, together, right? Fellow Americans. If you look at the Republican, like peace, freedom, world, America, law, right? So this way you can use a word cloud to compare different texts. All right. And of course, as always, you can remove like some of the unnecessary and some of the like irrelevant words if you want. So here it says like tokens remove stop words, right? Right now it's just removing stop words. You can, as I did previously, you can create a list of words that you don't want to see. Let's say, for example, like let, can, ago, right? These are not necessary. They're not relevant. So we can actually remove them. So you can just put them in a list created by you. And then here, rather than saying stop words and that list, as I did here. Unnecessary words. And then just put them as a list. And then all those words plus the stop words will be removed from your word clouds. Okay. Now, so let me show the last way of like visualizing a text, which is called lexical dispersion plot, which will tell us like the frequency of specific words or tokens throughout the text. Okay, so let's create that. So lexical dispersion plot. It's another way of like visualizing a text. So here again, I'm going to select. I'm not going to work because there are like 59 documents. It's too much to show in one plot, so I'm going to focus like some of them. So let's select some of those speeches. The first one, let's see. So data corpus inaugural subset, that's how am I going to name it, is equal to corpus subset. That function will take a subset of the entire corpus. So take the data corpus inaugural, the original corpus. But this time here, again, if you remember, we had the year variable, right? So using this year variable, we are just going to take the let's say the speeches that appeared after 1949. So year is greater than 1949. Okay, and let's run that. So now we have a subset of speeches, which includes the speeches that appeared after 1949. And using another function, which is called QWIC tokens, we are going to create the lexical dispersion plot. So take the data corpus inaugural subset, and then pattern is like which specific token that you will keep track of, which is, let's say, the term American, and continue working on that. So we're just going to create text plot X-ray, okay? Now we are not creating a word cloud, we are creating an X-ray, which is the lexical dispersion plot. Let's make some room for the plot to appear. I'm just going to run this line. Oops. Why not text? Oh, it's text plot, not text plot. Text plot. Still, yeah, there you go. Now, so this again, this is a typical lexical dispersion plot, and here every single row is a document. And remember, we are just focusing on the documents, the speeches that appeared after 1949. That's why it starts with 1953. Okay, starts with Eisenhower all the way up to Biden. And here we are looking for the word American, that's the pattern. Okay, and here you can see that for in the Eisenhower's speech, inaugural speech, the term American appeared in the middle of the speech. Okay, and in the second speech, the term appeared like a couple of times, like at the, I think, let's say after the half. But for example, if you look at the Trump speech, it appears a lot, like especially after the like almost second half. And if you look at the Biden speech, it appears all like everywhere, right? At the beginning, in the middle, at the end. Okay, so this way you can check if there's a specific term that you want to investigate. You can see where and how frequently that term is appearing throughout the text. So another way we can do is like in this case, we are looking for a specific term. We can also compare different terms. Okay, so to do that, let's say text plot, you can X-ray. That's how you, this is the function that creates the lexical dispersion plot. Now here, just make some space. So quick, the function, take the data corpus inaugural subset. The first pattern is, let's say, American. The second one, data corpus inaugural subset. The second one is, let's say, people, or let's say democracy. Let's run this and see how it's going to create. Let's run this. Oops, we're missing something here. Oh, I'm missing a comma between these two. Yeah. Now here, like this was the term American, and you can see for each speech after 1949, and this is the democracy. So Eisenhower never used the term democracy. And then Nixon, Carter, Reagan, they don't use. So Clinton uses a lot. Trump like doesn't use the term democracy, probably because like these, like Trump, all these, like Bush, all these are like coming from them, like Republican Party, right? That's the opponent. So, but Biden uses it a lot. Democracy, right? At the beginning, middle, at the end, right? So this way, this is the like second commonly used plot to visualize a textual data. Okay. Yeah, actually, yeah. Let me show one more, and then I'm gonna stop at that point. So let's go back to that word cloud. So if you want, we can color the word cloud by like based on the number of frequency. Okay, so for example, let's say we're going to create a text plot, word cloud, like text plot word cloud, using the original DFM inaugural, like original document feature matrix, which includes all the speeches. take that, and then let's say minimum count is 10. Okay, so if it appears less than 10, do not include that. And let's say we're going to define a pattern of colors. Okay, so color is equal to as a list. So let's say red, the first one, pink, green, oops, too many quotes, green, and then we will have purple. You can define different colors if you want. And we will have orange, and then the blue. So let's make some space. So if I run this, there you go. So this way, like, you can make your word cloud easier to read. And here is the idea. Like, let's go back to the list of colors. So we have this red, pink, green, purple, orange, and blue, right? So it's going to use the last one for the words that appears the most frequently. Okay, that's why government, people can ask becomes blue. It's going to use, let's say, the orange one for the words that goes like after blue, but in this case there's no orange. I don't know why. And it uses purple after that, and then the green. Probably, maybe orange does not exist. That might be the reason, because it skipped orange for some reason. But what you need to know is the first one will be used for the ones that appears the less, okay, less frequently. And it makes it a lot easier to read the plot, so that you can focus on the ones that appear the most. Okay. Yeah. And again, like, if you don't have any, like, if you don't have any R background, like programming background, these might be very overwhelming for you. But again, like, if you're interested in like text analysis, at some point you need to start working on R or Python. Okay. And then Python is also pretty powerful, but I think R is a lot easier to use and learn. So then you can definitely use these. But again, if you're into like, especially like text analysis using R, you should definitely spend some time on this website, okay? Because this is the main package that you're going to use if you're going to go with R, okay? And again, if you're interested in like working with Twitter, you should definitely spend some time on this web page, which is there are many other packages that you can use, but this is one of the best, I think, and easiest. As you can see, like, we can get the tweets by just how many lines? Just one line. You can technically get tweets about, like, say, timeline of a person by just one, like 2 lines. Okay, it's very easy. Okay. Do you have any questions? So I'm gonna stop at this point. Any questions?
Professor, could I ask one question
Yeah.
regarding the president's data?
Yeah.
First of all, thank you so much. I really learned a lot from R today. I was curious if, like, in the speeches, I think in this package, it it's all like lowercase alphabets. It transformed it into like all lowercase.
Yeah.
But I was curious because like I was kind of confused because I might have like missed it, but it says like us at US. So I was confused, like, is it like United States, or is like the president referring to like us in a way, so I was kind of confused about that word. So if like something like this happens in text analytics, I mean, do you have to go to the original data and kind of have to check it every time? I was curious.
Yeah, that's a good pre-question. So probably this us, as you said, includes both of them, like the word us and the United States, like US. And yeah, it's like probably it's here in this, like when we create the like document feature matrix or the tokenization. So here, if you look at the tokens, let's go back. The results, it's a little up. Yeah, here, like when we create the tokens, as you can see, it's taking them, like if it's a capital letter, it's taking it as a capital letter. But probably when it creates this document feature matrix, DFM function probably is converting them to like lowercase characters. So we might investigate that function. And I'm pretty sure there should be an argument that says do not, you see, to lower. This means like by default, if you do not specify, it is going to like change all the letters to lowercase. But here, if you say, let's try that actually. I'm curious what if it changes. So let's say typeplot DFM. So when we create this DFM here in this DFM function, let's say to lower is false. So do not convert it to lower. Let's see. Let's run this. Yeah, we have it. And which one was that? The last one, right? The last word cloud. Yeah, let's run that as well. Still running. Yeah, actually, it's just us, not US. Right? You see the Constitution. Now it's capital, government, capital, states. Yeah, yeah, that's a pretty good question. Yeah.
Thank you.
Yeah, like this way, like you don't have to, like, for example, I never thought about it. I mean, I thought about it, but I never checked it. And I don't know I didn't know the answer. But what I just did is like I just searched for the function, okay? So this way, as you can see, like each function takes many arguments and there's no way you can memorize all of them. Just like you just need to know to ask the right questions. And this happens usually with experience, okay? Yeah, thanks for the question. It's pretty good.
Thank you.
Any other questions?
Professor, I have a question.
Yeah.
I want to ask you about the Twitter API.
Mm-hmm.
And do you know about the way to extract the Twitter tweets about some keywords in each day? Because in the keyword Bitcoin, there are a lot of tweets in just one day. So it is difficult to extract every day's of tweets.
Like, do you mean like extracting the tweets for a specific date, or
like the 1 year's tweets?
Oh yeah, you can definitely do that. But here, as I mentioned, if you go to developer Twitter, so with the standard one, you can't. Okay, because it's well beyond the let's say the limits of the standard API. But here, for example, I have the academic API, okay, academic version. And for this one, you have to have a project that you're working on, okay? They ask a lot of questions for you to like grant this. so for example, with this one, I can pull like 10 million tweets a month.
Mm,
Okay, so what I did was, for example, and you can actually get the tweets from the first day of Twitter, which is I think someday in 2006. Okay, so what I did with this project, for example, I was collecting tweets about gaming.
mm,
Okay, so I collected every single tweet that includes the word gaming or hashtag, like the hashtag gaming, and then that's no problem.
mm.
So, but again, Bitcoin is a little different because it's very popular. It's being like, let's say, like tweeted a lot. So you might want to focus on to a specific location, specific language,
Mm.
okay, so that you can get some kind of like reasonable amount of tweets.
Can I get the results randomly by day, like the
Yeah,
one
like
day for 10,000 like this?
yeah. So like again, because it's tweeted a lot,
Mm.
and let's say when you run, let's say you run that search Twitter function, okay, and then here we said like 1,000 tweets, right?
Yeah.
About the Bitcoin. We got 1,000, but if you run it at the same time with me, you might get different 1,000 tweets,
Mm,
different set, because there are many. Okay, as
yeah.
as long as like you're like in the restrictions, okay, the limits, probably you will get like random tweets. But if your goal is this, I want to get all the tweets from the last 7 days, then you will get actually all the tweets about Bitcoin.
Mm.
And I'm pretty sure it's going to be huge, like probably millions of tweets.
Okay, thank you.
Okay, yeah. Any other questions?
Professor,
Yeah.
I want to be sure that you will share us the recorded video, right?
Sorry, could you ask again?
The recording video.
Yeah, this you mean this recording?
Yeah. Can you share that to us?
I think Mr. Kwon will do that because I'm not like it's a recording, but I'm not the one recording, so I'm not going to get the video. So Mr. Kwon, you can share it with them, right?
Oh, yes, Professor.
Yeah. So yeah, you can definitely get it.
Yes, thank you.
And again, before I actually, so I'm going to share this code as well. Okay, the R script that I created, I'm going to share this one as well with the class so that you can play with it. Okay. Any other questions?
Professor, could I ask one more question about Twitter? I kind of like in like a few months ago, I tried to like scrap a little information from Twitter to do like some text analytics. But the problem I encountered was that, you know, when Twitter, like people want to like up their retweet numbers, so they really like, you know, use like unrelevant keywords like hashtags to like make the search more like pop up more. So the thing was that I collected like for example like 100 tweets, but it wasn't really anything, wasn't even relevant about like the keywords I did. So like sometimes I think it really happens more on Twitter. Like, do you have like a way to you know, pre-process the data so that, you know, can be like used? Well,
Yeah.
it's really like subjective, but do you have any like?
So yeah, let me make sure I understand the question correct. So what you're saying that like when you, let's say, scrape the Twitter for a specific, let's say, topic, you get irrelevant tweets?
Yeah, unrelevant tweets, or like really like sometimes like useless tweets, like random words just, you know, stringing together.
But at the end they include the word that you are defining, right?
Yeah, a little bit, yeah.
Yeah, it's very hard to define this problem because it might be totally about the topic that you're looking for. Let's say, let me give you an example. So let's say you want to collect tweets about Apple, the company, but you're getting tweets about Apple, the fruit, right? That's a common problem. So what you can do is, like, rather than focusing on that specific term, Apple, it's only, you might want to like make your case a little distinctive by adding some other words that might appear in your or like relevant tweets. I think that's how I would do it. But again, it's a very hard problem. So like and that's the reality. So it's difficult. Like you're gonna have many like emojis, right? Many different yeah, text analysis is difficult, and Twitter is especially is very difficult. But again, like for your specific problem, I would enrich the words that I'm looking for in the tweet. That might be a way to solve it. Yeah, but by the way, like for any of these, like if you have any questions, you're more than welcome to reach out later. Okay, so like it doesn't have to be like about the topics. Like if you're interested in, for example, in my research, I do social media analytics a lot, but I do it from a network analysis perspective, like social networks. So like if you're interested in to talk more, just definitely you can reach out to me. Yeah. Any other questions? Yeah, I think we're done. Yeah, so it was very nice like meeting with you guys. It was I really enjoyed like teaching these like 2 lectures. And I hope you enjoyed and learned something that you can actually use in your personal life. Yeah, again, like if you have any questions or anything to discuss, just do not hesitate to reach out. Okay, like probably you have my email. If you don't, just like search my name and then probably will pop up. Okay, yeah, thank you very much, and I think it's afternoon there, right? Okay, happy like rest of your day then. Okay, thank you, bye.
Thank you, Professor.
Thank you.
Thank you.
Hey, Professor.
Thank you.
Thank you, Mr. Kwon, like organizing this and helping me with this stuff.
Thank you, Professor.
Yeah. Last thing, I'm just going to like send you a Kakao message, okay? I'm gonna send this R script that I used so that you can share with them.
Yes, Professor.
Okay, thank you, bye.
Thank you.